we will discuss about ionization energy today. Here in this lesson, we are going to discuss about the ionization energy and periodic trends regarding to ionization energy. First of all, we should know what ionization energy is. Focus on this M atom in the gaseous state. It has become M plus cation in the gaseous state and has removed an electron. So here some amount of energy should be given for this M atom in the gaseous state to become a cation. That energy is the ionization energy. So here in this definition it is said that the minimum energy required to remove an electron from the ground state of the isolated gaseous atom O n ion. I am going to modify it as O n ion. We can supply ionization energies for ions also. I am going to take this ion out. This is M plus cation. I am going to supply ionization energy on this M1 M plus cation in the gaseous state, and I am going to turn it for M2 plus cation in the gaseous state by removing an electron. So here the energy that we should supply for this M plus cation is also ionization energy. So an atom generally can have several ionization energies. That means like first ionization energy, second ionization energy, third ionization energy, like several ionization energies can be there. For hydrogen, there is only first ionization energy because there is only one electron. Likewise, for the number of electrons, there are ionization energies for that particular atom or ion. Then we will further study what first ionization energy is. First ionization energy is given for an atom, right? Only for atoms the first ionization energy is given. That means the energy given to form the first ion. First ionization energy, right? Energy required to remove most loosely bonded electron from neutral gaseous atom. Energy required to remove most loosely bonded electron. So I am going to draw a lithium atom like this, right? Here 2 electrons and here 1. If we say like this, energy required to remove an electron, like, so I can remove electrons from lithium from here, and from here, right? In the first ionization energy or any ionization energies, we are going to remove the most loosely bonded electron. Compared to these 2 electrons, the most loosely bonded electron is this one, because it is more far from the nucleus. So the energy that we should supply to remove this particular electron from lithium atom is known as first ionization energy of lithium. Energy required to remove most loosely bonded electron from neutral gaseous state atom is first ionization energy. Second ionization energy. Second ionization energy is the energy that we give for monovalent cation to form its second cation. Second ion formation energy, second ionization energy. Likewise, right? Energy required to remove most loosely bonded electron from monovalent cation. Monovalent cation means single positive charged cation, right? Here M plus gaseous cation is there. Second ionization is given to this an M2 plus cation, an electron is formed. This is the electron that was removed, and this is the M2 plus cation that was formed, right? So we can't straight away give this second ionization energy to neutral atom like this. M gaseous atom is there, we give second ionization to it, and M2 plus cation plus 2 electrons like thing doesn't happen. This incident is not happening. We have to first of all give first ionization energy and form the first cation, and then we should supply the second ionization energy to the form second cation. So that is the way. We are going to compare the ionization energies. That means something like this. I'm going to ask you something like this. Lithium atom. Lithium atom has 3 ionization energies as first ionization energy, second ionization energy, and third ionization energy. What ionization energy out of these 3 has the highest value? How do you think about it? So, now I am going to teach you the way to find the highest ionization energy from this. I will draw lithium atom like this and this. This is the lithium, and here lithium plus, and here lithium 2 plus. Here lithium 3 plus. It should be something like lithium 3 plus. Then here 3 electrons are there in the lithium atom. In lithium plus 2 electrons. In lithium 2 plus 1 electron. No electron are there in lithium 3 plus. Right? So here, look at this. Lithium atom has 2 energy levels and radius of it is comparatively higher than any cation. Right? So, to the outermost energy level, the distance from the nucleus is higher. By supplying the first ionization energy, we remove this electron. Right? Then by supplying second ionization energy, we should remove this electron or this electron, both same. I am going to point this one here. Right? By supplying third ionization energy, we should remove this particular electron. So you can see here, radius becomes less when charge increases. You have learned it in previous videos. When the charge increases, cation radius become low. So here, when the cation radius becomes low, nuclear attractions increases. Then when the bond increases, when the attraction increases, it is more harder to remove electrons. So if we say that first ionization energy, second ionization energy, third ionization energy, like third ionization energy is the highest, first ionization energy is the lowest. What is the reason behind it? When the charge increases, atomic radius becomes less. When atomic radius becomes less, the distance between the outermost electron and the nucleus become low. Then the nuclear attractions become higher. So it is more harder to remove electrons, so that ionization energy becomes higher. There are 2 factors affecting the ionization energy. They are radius and the Stability of electronic configuration. Factor affecting the first ionization energy is radius. I have mentioned it as radius because cation radius and atomic radius both affect on ionization energy. We know that when radius becomes low, attractions from the nucleus to the outermost energy level increases. That means nuclear attractions increases. When nuclear attractions increases, those electrons bound to nucleus tightly, right? Then it is hard to remove electrons from the cells. In such situations, ionization energy is higher. So we can say that when the radius decreases, ionization energy increases, right? So you should keep in your mind that when the atomic radius or ionic radius becomes low, the ionization energy that we should supply is high. One factor affecting the first ionization energy is stability of electronic configuration. So think like that atoms are you. When you're stable, do you want to let go your stability? You never do it, right? Like that, atoms like their stable or half stable conditions. So in such situations, it is very hard to remove electrons from stable or half stable atoms or ions. So when atoms or ions are in stable or half stable conditions, the ionization energy that we should supply is comparatively higher. We are going to discuss about the periodic trend of ionization energy. So across the period, there is a variation of ionization energy, and we are going to compare and see what kind of variation is there, right? So first of all, I am going to write common configurations of elements in the groups only considering S and P blocks, right? That means considering first 20 elements. We are not discussing the first ionization or any periodic trend here regarding D block and F block elements. We are only focusing on S and P blocks. So I am going to write the common configurations to understand this variation, right? So first group like hydrogen, lithium, sodium like elements are there. What is the common configuration of that? N is 1. Moving to second group, there is beryllium, magnesium like elements. So Ns2 configuration can be there. Then in the third group, boron like elements are there. Ns2, Np1 common configuration is there. Likewise, Ns2, Np2, Ns2, Np3, Ns2, Np4, Np4, Ns2, Np5, Ns2, Np6, Ns2, Np6, right? So these are the common configurations. So focusing on this, you can see here stable configuration. And here is another stable configuration. And here is another stable configuration. So what are the groups of them? Here this is the second group, here fifth group, and here eighth group. So in this, stable and half stable conditions can be seen. Their ionization energies should have higher values than the others. So, if I draw an ionization energy variation graph like this, ionization energy variation graph across the period, right? Here I am going to draw the ionization energy variation graph across the period considering the common configurations. So first one is NS1 configuration. For that, hydrogen, if we consider hydrogen to be the atom that we draw, it has higher first ionization energy because that is the only electron in hydrogen. But I am going to draw this graph in common. But when you should keep it in your mind that if you consider this for hydrogen, it has high energy in NS1 level. So here NS1, I am going to draw it in a position like this. NS1 is a first group. Then NS2. NS2 is stable. So it should have high energy than the first one. Then NS2NP1. After removing an electron, it becomes stable. So it is willing to remove electrons. So ionization energy should be low. Third group have low first ionization energy. Then fourth one, NS2NP2. More than this ionization energy should be there because outermost shell has 2 electrons. It should remove 2 electrons to become stable like. Then NS2NP3, fifth group, half stable. They do not like to remove electrons so that they should have high first ionization energy. Then NS2NP4. After removing an electron, it can become stable. So the ionization energy should be low. Then NS2NP5. NP5, it should gain 1 electron to become stable. It should remove 2 electrons to become stable. So first ionization energy should be somewhat higher than this 7th group. Then the 8th group noble gases NS2 NP6 configuration, all the orbitals are filled. So the highest ionization energy is in that one. We will discuss down the group ionization energy variation. When going down a group, number of energy levels of an atom increases. When number of energy levels increases, atomic radius or cation radius increases. Then nuclear attractions become low. When nuclear attractions become low, it is easy to remove an electron from the outermost energy level. So ionization energy that we should supply become low. So as a conclusion, we can say when going down the group, ionization energy decreases. Thank you for staying till the end. Goodbye.